Find the curve in the xy plane that passes through the point 9, 4, and whose slope at each point is 3 times the square root of x. So let's think about what's given to us here. We have a point on the curve, or on f of x. So we have that xy is equal to 9, 4. So this point on the curve is our initial condition. And we're also given that the slope at each point is defined by 3 times the square root of x. So remember, the slope is going to be equal to the derivative of our curve at this point, or at any point x. So we can say that f prime of x is equal to 3 times the square root of x. And this question is asking us to find the curve that satisfies this slope and this point. So we want the particular solution. So we know when we want a particular solution given some information like we are here, we need to start by first finding a general solution. So step 1, find the general solution. Find the antiderivative for an arbitrary c. So the general solution will be the integral of the derivative dx, which is equal to the antiderivative plus that arbitrary constant c. So we have the integral of 3 times the square root of x dx, and we can rewrite this as 3 times the integral of x to the 1/2 dx, and we're ready to antidifferentiate. So this will be equal to 3 multiplied by x to the 1/2 plus 1, all divided by 1/2 plus 1, and then don't forget about that plus c on the outside. So this will become 3 multiplied by x to the 3/2, all divided by 3/2, plus c. And we know fractions in the denominator will flip. So we have 3 multiplied by 2/3 times x to the 3/2 plus c. And these 3's will cancel each other out, leaving us with the general solution. Or we can say the general solution, or the general curve, defined as f of x is equal to 2 times the square root of x cubed plus c. But again, we don't want the general solution, we want the particular solution. So step 2 is to use the initial condition. So remember, our initial condition was 9, 4, and we want to use the initial condition to find c. So our initial condition, xy, or even we can think about this as x f of x, is equal to 9, 4. So plugging this into our general solution, we have that f of 9 is equal to 2 times the square root of 9 cubed plus c, and we know that this will be equal to 4. Giving ourselves enough room here. So we want to simplify this radicand first. I'm going to switch the order of the exponents just to make our calculations a little bit smaller. So we can equivalently rewrite this as 2 times the square root of 9 cubed plus c is equal to 4. And again, that's using our properties of exponents here. Remember, if you have a raised to the m by n, that's the same thing as saying a to the m raised to the 1 over n, which is the same thing as saying a to the 1 over n raised to the mth power. So that's what we did down here. And we did this so that we can take the square root of 9 first, which leaves us with 3. So now I have 3 cubed plus c is equal to 4. So we have 2 times 27 plus c is equal to 4, or 54 plus c equals 4, which leaves us with c is equal to negative 50. So we have that particular arbitrary constant c, and we can say, therefore, the particular solution of the curve is now officially defined as f of x is equal to 2 times the square root of x cubed minus 50. And this is our beautiful final answer.